Hello everyone, welcome to another video of the course. In this video, I am going to generate the model geometry, the motor geometry in the SolidWorks software, and then we import the model into the ANSYS Maxwell software. So I will do two-dimensional finite element simulations, and I will explain to you how we can prepare the geometry suitable for two-dimensional simulations. So here you can see the motor parameters. I explained these parameters in the previous video, and this is the motor. So first, let's have a look on main dimensions of the motor. Actually, the radial and axial size of the motor. The outer diameter of the motor with housing is around 80 millimeters. You can see here. And the total axial length with housing is around 65 mm. So this is the stator and winding. In this motor, we have two identical coils, phase A and phase B. So we have two identical coils, and we have a capacitor in series with one of them. Okay, so this is the side view, and this is the top view of the motor. And as you can see here, because this is a low power motor, the output power is low, and the stack length is low, we have a high axial length for the end winding. And as you can see here, the end winding is comparable with the stack length of the motor. So this figure shows the end winding. Actually, I cut the end winding to be able to count the number of turns in each coils, and also to be able to remove the winding from the stator. So this figure shows the stator core and the stator winding without this end side, and how I removed the winding from the stator core. And this is the stator winding. Also, you can see the stator core and a slot insulation. Here in this figure, we have the stator core and a slot insulations. Finally, we have these parts for the stator core. Stator core, a stator iron core, winding, and a slot insulations. Okay, this is the stator lamination, single stator lamination. We have slots. Actually, this is a slotted stator, and you can see that in this image I removed this single lamination from the stator core. So this is the stator core and a single lamination. So here we have these two dimensions for the stator core. This is the outer stator diameter, and this is the outer stator width. So we have many ways to create this geometry, and I will use the SolidWorks software and explain you how we can generate this geometry. So in the SolidWorks software, I create a new file. I select the part, press OK, and let's save this to desktop. I created this new folder for single phase induction motor. I write here single phase induction motor, and I press save. So as you know, the first step in any CAD software is creation of the sketch. We have three planes here: front plane, top plane, and right plane. So I select the front plane and I create a new sketch. And from this tab, sketch, I select this circle first, create this circle, and again, I draw another circle and I press OK. So now let's set the diameter of these two circles. This is the outer stator core diameter, that is equal to 80 mm. So I write here 80, and this is the inner stator diameter, that is equal to 48. This is the stator bore diameter, inner stator diameter. I write here equal to 48. And I press this option and I press exit the sketch. So this is just a sketch, and now I use the extrude option, extruded boss, to make a solid object. So you can see I can create a solid object from that sketch using options that I have here. So from this option, I select mid plane. I want to have the X and Y plane to be in the middle of this hollow cylinder, right? So if I select blind, so this is the XY plane. But if I select mid plane, the XY plane is in the middle of this hollow cylinder. This is good because I will generate 2D model in the ANSYS Maxwell software. I create the geometry like this. So what is the motor stack length? The stack length of the stator core, you can see stack length is 16 mm. So this is the motor stack length. You can see the stack length here, that is equal to 16 millimeters. So I write here equal to 16 millimeters and I press OK. So this is the stator core. Now I want to remove sides of the stator core using this option that I explain it now. I select this face and I create a sketch, and then I draw a rectangle here. I press OK. Then I create a center line here. This is not actually a line. This is just for setting the geometrical constraints, and I set it horizontal, and let's set its size equal to what is the outer stator width equal to 74, right? So I write here 74 divided by 2. And I press OK. Here I write, for example, 85. Not important, just higher than the outer stator diameter. And I press OK. So I have this sketch and I can use this option, extruded cut, from here through all bows to cut everything that is inside this sketch, and I press OK. You can see it here. And also I create another sketch, and from here I select the center line. I set the center line and I place this point in the middle of this segment. So as you can see here, this segment, this center line is dark. Its color is dark. That shows that this is fully constrained. So I draw another center line here and I press OK. Let's draw a circle. Draw a circle here. OK. According to this geometry that we have, these 4 circles, and I press OK. So let's set this angle that is equal to 45. OK. And let's set the diameter of the circle that is equal to a stator guide hole diameter. Stator guide hole is equal to 3 mm. So I set diameter of this hole equal to 3 and press OK. What is this length? What is this length? It is equal, according to this, I measured the distance between 2 holes in diametrical direction, that is equal to 7t. But as you can see here, I should subtract the hole diameter from this number, right? So actually this is 70 divided by 2. I mean this dimension. This is 70 divided by 2 plus 3 divided by 2. That is the radius of this hole. And I press OK. Right? This is 70 divided by 2 plus the diameter of this hole divided by 2. And I press OK. Again, I can use extruded cut and select the through all bows, press OK. These 2 cuts. So now I select this plane and create an axis here, this axis, to be able to rotate these 2 cuts. So from here, linear pattern, I select circular pattern and I select this axis. The number is 4 and the angle is 90. What features? These 2 features, this feature and this feature. And I press OK. So you can see the stator core here. Now let's create the stator slot. Again, I select this face, new sketch. I draw a line here. Let's plot the line. So let me change it to guideline, the center line. And we have a stator slot dimensions here. The width of a stator tooth is equal to 5 mm, and this depth of the slot is equal to 6 mm. So I draw this arc here. I draw this arc here and I press OK. So this is my arc. Let me draw another arc, this arc. I place the center here, this arc, and also I draw another line like this, and finally this one, something like this. Right. So this is the geometry of stator slot. And now I select these 2 points and this guideline and place symmetric constraint. Okay. This line and the center coincident. Okay. Also, I can set the value, the distance between these 2 lines, or the distance between these 2 points. That is actually the slot opening, this number that is equal to 2 mm. So I write here 2, I press K, and now I can set other constraints, this point, and this symmetric, okay, this point, this guideline, symmetric, okay. Also, I select this arc, this point, coincident, constraint, and I press OK. So the next constraint that we have is this one. So also let me set the symmetry constraint for these 2 points. Okay. As you can see here, when I move this point is moved correspondingly. So I select this segment and this arc and use this relation that is tangent. Okay, let me check. First, let's draw this center line and use this option, this center line, this line are in parallel. Okay, make these 2 center lines in parallel. Then let's set the value of this angle. This is the half of a stator slot angle. As you can see in this design, number of stator slots are equal to 1, 2, 3, 4. 4 by 4 is 16. So this is the half of a stator slot angle, 180 divided by 16. So I press OK. And now let's set the value of the width of a stator tooth, that is equal to 5 mm. I select this edge and click on the center line. So this is the width of a stator tooth, that is equal to 5 mm, as you can see here. And I press OK. Now let's select this line, make them tangent. Right. So because we have tangent circle, to this line, as you can see here. But it seems that I should use another constraint here. I should use another constraint here, or may I have an extra constraint? Maybe, because I cannot change. Right, because maybe I cannot change the value of this circle. Right. Anyway, so let's use a constraint here. Let's use a constraint here. So the first constraint is this dimension, the HS1 actually, HS1 and HS2. Actually, in this geometry, this is HS1, excuse me, HS0. Also, we have HS1, and finally, we have HS2 here. So let me check. The value of HS0 is 1, HS1 is 1, and HS2 is 6. So here, this length, this is equal to 1. That's okay. And also, this is approximately, we can write here, the stator bore diameter divided by 2, 48 divided by 2 plus 1. 48 divided by 2 plus 1. And I press OK. So we know that this arc should be in tangent with this. So, right. Now, OK. And as you can see here, we have a fully constrained model. But also, I should specify this, the horizontal distance between these 2 points, that is equal to 6, according to this number, HS2, that we have here, right? The value of HS2, that is equal to 6 mm. So I press OK. OK. This is the stator slot sketch, and I can use extruded cut, direction through all bus, and I press OK. So this is one stator slot. And again, I can use the circular pattern to select this axis and this feature here in the feature option. So total number is 16, and the angle is equal 360 divided by 16. So I can press OK, and you can see the geometry of stator core. So how we can create the stator winding geometry? I select this face and create a new sketch, and I select this edge, and from here I select offset entities. So this is offset of these 3 edge objects. I write here 1 millimeter in reverse direction. So the thickness of S-dot insulation is not 1 millimeter, it's equal 0.3, and here I write 0.3. So I press Okay, let me also select these two edges, offset entities in reverse direction, and I press OK. So I can draw an extra line here to close this polyline and press OK. So this is geometry of one coil. Exit sketch. And now I can use the extruded boss. So this is the start. And I want to extrude this sketch up to a surface, up to this surface. So anytime we don't have to set the stack length for this winding here, right? That is equal to the stack length of the stator core. And I press OK. This is why, because I want to generate two-dimensional model. If I want to generate a fully three-dimensional model, also I should create the geometry of end winding. So for a better visualization, I can select this object and from material, set its material equal to copper, just for a better visualization. And now let's save the model. I select this object and circular pattern, select this axis, 16, and again 360 divided by 16. And I press OK. So let me check, excuse me, node feature, I should select bodies, and I select this object. This is a body, not a feature. So I press OK. Now, as you can see here, I have the geometry of a stator core and a stator winding here. So let's pause this video and continue creation of the rotor geometry in the next video. Thanks for watching.